Hello and welcome to our learning series on machine learning. Today we are going to explore the classic iris species classification project. So it's a perfect start for anyone who is new and want to learn machine learning. So this iris classification project will consist of the iris flower dataset, iris flower dataset, which was introduced by a person called as Ronald Fisher in 1936. So that dataset included three species of iris flowers. So they were known as iris setosa, iris versicolor, and iris virginica. So here, what is our task? Our task is to predict the species, based on the four features called as sepal length, sepal width, petal length, and petal width. So let me show you an example. So this you can see, this is this species of iris is called as iris versicolor. This is called as iris setosa, and this iris virginica looks like this. So you see this this is called as sepal. This is called as sepal, and this leaf is called as petal, right? So not leaf, but it's part of the flower. So so this sepal is slightly more in width compared to petal. So given the random iris species, what we'll do, we'll measure its sepal length, sepal width, petal length, and petal width, right? And based on that, these measurements of sepal and petal will predict whether this is this is an iris versicolor or iris setosa or iris virginica. So that's our problem. I hope the problem is clear. Given a random iris species, we will measure its sepal length, sepal width, petal length, and petal width, and we will predict whether that flower is iris versicolor, setosa, or virginica. So that's the problem statement. So now let us we are going to use the Python libraries like scikit-learn, pandas, and cborn to build and evaluate our model. So let's first explore our data set. So let me write the code from scikit-learn dot datasets. We are going to use the dataset from scikit-learn. We are not going to download the dataset from any website or from any other resource. We are going to use the inbuilt dataset which is available in scikit-learn. Load iris, name of. So this will load the dataset iris, right? This is the name of the dataset belonging to iris. Then I'll need pandas. Import pandas for data frame, creating the data frame. So pandas as PD is the alias or the shorter name for pandas. Then we'll need cborn for plotting the graphs or pair plots. Import cborn as SNS, right? Then we'll need matplotlib again for plots, pyplot as plot plt, right? So these are the libraries which will require. So let's wait for those libraries to, let's wait for this code to get executed. So by the way, I'm using Google Colab here. If you want, you can use Google Colab, or you can use the Jupyter Notebook. So it's your choice. Right now we have these libraries available with us. Now I'll load the iris dataset. Iris is the name of the variable which will hold the dataset. Load underscore iris. So we are creating the object of this load iris type. We are creating this iris is an object or which is a variable of this load iris type, right? So this will, so iris, right? Then we'll create the data frame from this iris. We'll create the data frame from this iris object. So iris underscore df is equal to pd pandas. We are creating the data frame from pandas. Iris dot data, right, comma, then we will say a column is equal to iris dot feature underscore names, right? So this is our iris data frame, iris underscore df. We have created this data frame from iris dot data, from the data of this iris, right? From the data part of this iris, right? And the column is iris dot feature underscores name. So these are the columns. These are the columns in the data frame, right? Iris dot feature underscore names. Let us execute this. Yeah. So now let's look at our data frame, right? Iris underscore df. We'll see only the top 5 rows. That's our head. So you see that is how our data frame looks like. We have columns called as sepal length, right? So these are the feature names, right? What are the features for iris flower? The features are sepal length, sepal width, petal length, and petal width. So these are the 4 columns here, right? So for example, first flower, this is the first flower's data. So the first flower's sepal length is 5.1 in the centimeter. Sepal width is 3.5 centimeter. Petal length 1.4 centimeter, and petal width is 0.2 centimeter. So likewise for each iris species, the data is stored in the data frame, right? Okay, so now we will have iris species, right? So this is iris data frame. Iris data frame contains the data of the iris flowers with 4 features, right? And then we will have the species names, right? Iris underscore df of species is equal to iris dot target underscore names, iris dot target. So let us execute this. So now let's see again iris underscore df. Yeah, you see now this column is added, species column is added, right, which was not there earlier, right, which was not there earlier in the iris df. Now here we added the species column indicating what is the name of this species, iris species. It's a setosa. Name of the species again setosa. Then we have virginica and so on and so forth. So we have 150 rows and 5 columns, 4 for the features and 1 for the species, right? So that species we added from the iris dot target name. So this holds the names of the species. Okay, so then we'll do some exploratory data analysis with our data set, right? So in order to know our data set very well, which features are very useful, which features are not useful, we'll do the exploratory data analysis. And for that, first we'll visualize our data with the pair plots, right? So SNS means seaborn. From seaborn will by using seaborn we'll plot the pair plots. pair plot, and to this we'll pass iris underscore df, the iris data frame, and hue is equal to the species, and then we'll say plt dot show. So let's see. So let's see, let's wait for this. Yeah, we have got the pair plots here. Then, if you see in this pair plots, we are plotting the each feature against each other feature, each feature against the other features, right? So for example, you see here sepal length is plotted against the petal width, sepal length is plotted against the petal length, right? So you see the hue here is the species. For example, if you see these are versicolor, you see this is these are species, setosa, versicolor, virginica are green, right? If you see that means if you see by using the petal width and petal length, we are getting a clear distribution and clear separation among the species, right? For example, this these are virginica, these are versicolor, and these are the setosas. Probably setosas have very small petal width and very small petal length. On the other hand, the versicolor have medium petal length and medium petal width and petal length, whereas virginica have the higher petal width and the petal length. So you see, by having this pair plots, we can have the clear understanding of which features are useful and which features are not useful, right? So that's the use of pair plots. They show the scatter plots for each pair of features in the data set. For our example, we have a sepal length, sepal width, petal length, and petal width, right? So this show these pair plots again show which features are related to each other, and this is very crucial in the understanding of our understanding the correlation and patterns in the data, right? And then by coloring the data points based on the iris species, right? Setosa, versicolor, and virginica, right? So these pair plots are providing us the clear indication of how well these species are separated in terms of these features, right? So now after having these pair plots, let's go to the next point by so let's move on to the next point, and next we will would like to build our model, right? After having the pair plots, we'd like to build our model. We will decide which the classification algorithm to use, whether to use the decision tree or the logistic regression. To begin with, logistic regression is decision tree, and logistic regression will be the best choice, right? Okay, so before building the model, we'll be dividing our data set into the training and testing data set, right? So training and testing in the ratio maybe 70-30 or 80-20. So right, so we'll divide our data set into training and testing. So from I'll need some libraries here again, from scikit-learn dot model selection, import train test split for training, dividing the data set into training and testing. Then I'll need the model here, so I'll be choosing the decision tree classifier. So from scikit-learn dot tree import decision tree classifier, okay. So I need these two, right? Okay, now let's divide the data into xtrain and xtest, comma ytrain, ytest. So this x will hold the input and y will hold the output, right? That means y will hold the species name, whether it's setosa, virginica or versicolor, that y will hold, and x will hold the features, right? The length, sepal width, petal length and petal width. So that's what x will hold, and y will hold the species name. That's the target. Okay. So then which is equal to train, test, split, and here we'll pass our iris dot data, comma iris dot target, comma then we'll pass our the test size, right? So test underscore size is equal to 0.3. So this and then we'll pass the what is called as random state is equal to 40. Usually we take 42, right? 42. Now iris dot data will give the four features, right? What are those four features? Sepal length, sepal width, petal length and petal width. So iris dot target will give us the species name, setosa, virginica, versicolor, right? The test size equal to 0.3 means 30% of the data set we want to use for testing purpose, and random state 42 means the use of random state is whenever you run this code, right? See what we are doing here, we are randomly dividing our data set into 70 and 30, 70% training and 30% testing. So now when we don't define the random state variable, at that time when you run this code, every time you run this code you will get different splitting, different data in training and different data in testing, so it may affect the result. So when you define random state is equal to some number here, and that time whenever you divide, whenever you run this code, you will get the same split, same data in training and same data in testing. So that's the use of random state. Okay, so let's run this. Yeah, so we got the xtrain, xtest, ytrain, ytest. So now we'll build our model. So model is equal to decision tree classifier, right? So this model is a variable which is holding this object of this decision tree classifier. Now we will train this model. Means we'll pass the training data to this model. So training of the model means we are giving features, and we are also giving the target variable. So we are giving four features. We are to the model. We are giving sepal length, for example. We'll give this. We'll give this to the model. We'll tell sepal length is 5.1, sepal width is 3.1, and petal length is 1.4, and petal width is 0.2, and the species of this is setosa. So this setosa is held in Y. So we are giving this X, right, as well as Y. So we are giving this input to model. So model is learning for setosa, what is the sepal length on an usually what is the sepal width, and petal length, right? So model is learning from that. That's called as training, right? So we are giving 70% of this data, 70% of our data to train the model, right? Okay, so now that's called as training the model. So model.fit is model.fit means train the model by using xtrain. Xtrain means we are giving the 4 features here, and ytrain is the corresponding the species, right? So let's see, now our model is getting, yeah, our model is trained now. Now let's evaluate the performance of our model, how well our model is trained, right? We'll calculate the performance of our model. We'll evaluate the performance of our model. So we are going to use accuracy and confusion matrix, right? So accuracy is very simple. Accuracy means, you know, out of, let's say, 100 predictions the model has made, how many are correct, right? So that is called as accuracy. And confusion matrix is like a table which gives us correct and incorrect predictions, right? So it will consist of the 4 components: true positive, true negative, false positive, and false negative. So true positive means if the instance is belonging to a positive class and it is predicted to be positive by our model, that is called as true positive. True negative means an instance is belonging to negative class and it is also predicted as negative by our model. Then false positive means the instance is belonging to negative class but it is incorrectly or falsely predicted as positive by our model, right? So likewise false negative, right? So that's what confusion matrix consists of. So we'll use confusion matrix and accuracy as our evaluation parameters. So from scikit-learn dot matrix import accuracy score comma confusion matrix, right? So we will have accuracy score and confusion matrix, right? Then we'll evaluate our model. We'll call ypred. Ypred would hold the evaluations, right? Made by the predictions made by the model. Model dot predict x test on this model which we have built. This fit means training and predict means we are passing the test dataset. See, model is trained by using the train dataset, right? So now we are also having x test and y test. We are giving model only x test, right? And we are seeing what y's model give, what species model give, and we are going to compare those predicted species with the y test, right? Y test is holding the species of the test dataset, right? So we are going to ypred is going to hold those predicted species. So let's see. Now yeah, ypred we got. Then we will print the accuracy. Print accuracy is accuracy score. Accuracy score. To this accuracy score we'll pass y test and y test, which are actual y's, right? Which are actual y's of the x test, right? And we'll now also pass the ypred, which are the predicted y's, which are predicted species. This is y test is holding the actual species and ypred is holding the predicted species. Pred, right? So let me execute this. So accuracy is 1.0. That means, yeah, the 100% predictions are correct. 100% predictions made by the model are correct, right? Okay, then we'll print the confusion matrix. Print confusion matrix. And to this confusion matrix again we'll pass y test and y pred. Oh yeah, this is the confusion matrix. So this row is called as, you know, these are actual and these are predicted, right? So this is you see the columns hold the true positive and true negative, right? And these hold the false positive and false negative, right? We want to have the as many true positives and true negatives as possible, as many true positive and as many true negatives as possible, right? So so here, you can see we hardly have false positive and false negative, which are off diagonal elements. On the diagonal we have true positives and true negative, and off diagonal we have false positive and false negative, right? So we don't have any false positive. That means we don't have any misclassification or wrong predictions. We don't have, right? So that's the confusion matrix. I'll talk about confusion matrix maybe in some other video, right? Okay, then finally what we'll do, we'll use our model to make the predictions on new data, which is not in training and testing, right? So we'll use the new data. So let's say new data is equal to 5.1, which is sepal length, 3.5, which is sepal width, let's say 1.4, which is petal length, and 0.2, which is petal width, right? So why this is in 2D? Because the model expects the input to be in 2D, right? So this is new data. And then we'll see what is the prediction made by our model. Prediction is equal to model, this is prediction, model dot predict, right? So we will pass the new data. So model will make the prediction, right? Okay, prediction is holding, this prediction will be a number, by the way. This will be a number. What number it will have? You see, this will hold the index, right? This will hold the index of the sepal length, sepal width, petal length, and sorry, not sepal length, but the index of the species, right? So this the index of let's say setosa is 0, index of virginica is 1, and versicolor is 2, right? So this will this prediction will not hold the name. This will not hold the name, right? This will hold. This is going to return us. This is going to return us the index of the, because the index of the species. Index means these species are stored in an array. These species are stored in an array. For example, iris dot target underscore names, right? So the species are stored in an array called as iris dot target underscore names, right? So this array is holding the setosa, then versicolor, and virginica. So likewise, right? So now the index of setosa is 0, index of versicolor is 1. For example, I am telling you index of virginica is 2, right? So this is going to return us this index, not the name of the species. Now it is our job that from this index we will get the name of the species, right? Okay, so we have got the prediction for this. For this we have got the prediction, right, in the prediction variable. Now we'll see what is the prediction made by the model. So print f predicted species is iris dot target. From iris dot target underscore names we are going to get the species names, target names, prediction, right? We are going to this will return us the prediction is a number, right? So iris dot target underscore names, and this will replace the number, right? 0, 1 or 2, right? And then 0, then 0. The meaning is this will return us an array. This will also return us an array. From that array, we want the 0th element, right? We want the 0th element. So I'll show you. Just let me first print this. Yeah, setosa. You see this. Now what? Now if I don't write this, let's see what we get, right? You see, we are getting this. That means we are getting this as an array, right? This is getting written as an array, right? So see, you see, if I print, iris dot target target, you see this iris dot target underscore names. This is an array, right? So right, this is 0, 1, 2, location 0, location 1. Now this let's say this prediction is 0, right? This is 0, so it will be iris dot target underscore names of 0. So this will return as setosa. This is returning us as an array. I don't want an array. I want the first element, 0th element of this array, because this space is in the 0th element. That's why I'm putting this 0 here, right? So now you see, now I'll get this setosa. Okay, so this is the classical iris species classification project. I hope you understood. We have successfully built and evaluated the model to classify the iris species, right? So thank you so much for watching.